previous lecture we talked about vectors and the two coordinate system in which we can express vectors, and in this lecture we'll talk about adding vectors. Now, what is the meaning of adding vectors? So let's take an example here. Let's say you live somewhere here and I travel to my friend's house, Peter, and after I spend some time there, I travel to my other friend's house, that's John. Now, if you ask the question, what is the final position, what is my final position with respect to my initial position, then what would you do? Or you can say, what is going to be the resultant of these two motions or these two travels? What is going to be the resultant? Well, this is the resultant, right? So the resultant of going from here to here and then from here to here is this particular arrow. Similarly, let's take another example. Let's say, so this was 1. Let's take another example. Let's say you have a wooden box and you are applying a force. So what will happen? If you apply a force, this wooden box will start moving upward. But let's say your friend Peter comes along and he starts applying a force in this direction. What would you observe? You will see that the box actually starts moving in this direction. So what does that mean? Which means the resultant of applying this force and this force is this yellow force. Now, how can you draw this vectorially? Well, if you look closely, let's get to the right color. You first applied the first force, which is same as traveling from me to Peter, and then your friend comes and applies the other force, which is same as going from Peter to John, and then you're looking at the resultant. Do you see a similarity in these two examples? Right? So this is what addition of vector means. It gives you the resultant of two physical processes, or like in the first case it gives you resultant of two displacements. In the second case it gives you resultant of two applied forces, and you can write this in a symbolic way as, let's say you applied, there's a vector like this and a vector like that, and then this is the resultant, and symbolically you can write this as A, B, C, and symbolically you can say AB plus BC equals AC, right? And I did not draw the Cartesian axis, or I did not draw the axis system all the time, but you can have the axis system. You can draw the axis system. It was sort of understood that axes are like this. I'm sorry, I can't draw straight lines. Okay, here, and this is the resultant. Let's label them A, B, and C. Well, this was all pictorial. How would you apply it in physics or in terms of numbers? Now, we already have talked about the Cartesian representation of vectors, and let's say the Cartesian representation of vector AB is AX comma AY. Remember what was AX and AY? AX and AY was the projection vector makes on the x-axis and on the y-axis. Similarly, let's say the Cartesian representation of vector BC is bx comma by. Again, this is going to be, sorry for the clumsiness here, this is, what is this, by, and similarly this base is bx. Let me draw arrows, right? So this is by, this is bx, this is ax, and this thing is ay. So now we want to find AC. What is AC? What is the Cartesian representation of AC? Well, which means how can you obtain AC? Well, if you look closely, then you can obtain AC if you let's use a good color. If you travel like this and then you travel like this, which means we are trying to figure out the Cartesian representation of AC. And if you look closely, you will see that the projection of AC on the x-axis is AX plus AY. Similarly, if you look closely, you will see the projection of AC on the y-axis is BX plus BY, isn't it? Oh, I'm sorry, I did a mistake here. The projection on the x-axis is AX plus BX, and similarly the projection on the y-axis is AY plus BY, and this is nothing but AC. That's how we define the Cartesian representation of a vector. The Cartesian representation of a vector is how much you have to travel on the x-axis and then on the y-axis to go from A to C, and that's what we have obtained if you use simple geometry. So whenever you have two vectors, find the Cartesian representation and use this formula. This is an important formula, very important, and use this formula to add two vectors, right? So this was all about adding vectors, and we'll not talk about vectors for another 2 or 3 classes. In the next class we'll start kinematics, or motion in a straight line.